Let's first run our program. It waits for inputs. We need to send inputs using TCP, and it loads images. Let's see what we sent. We sent one. Let's open new image memories. Okay, this is the raw initial point cloud that we obtained. This is only a metal object point cloud. This is the point cloud that we finally aimed. The whole calculations are done in this point cloud. And this is the points that are excluded. We don't consider these points. Okay, so let's put these marks next to the commands which are requiring more time to operate, because we don't want to wait anymore. And EVT program generally runs unexpectedly when you double click into one command. Okay, this is the initial raw point cloud. We first separated this background surface and this plane from each other. As you can see, there are two objects. After we separate those two objects from each other, we sort them considering their point clouds, and then we get the metal object, which is located in 1 first index. Then we apply straightening operation. So we make this surface straight. After we estimate a plane to that surface, we again need to separate those points. We did that, we classify the objects, and then we get the metal object using this command again. And then we find the edges. These 4 find edges commands finds points which are at the very end. These points can be deceptive for our calculations because there is curvature in the object, and we need to find lowest and highest points. So that's why we excluded these points. Then we subtract these points from the point cloud of the metal object. Here in image memory 1 you can see just metal object, no background surface anymore. This point cloud doesn't include these white edges. Okay, it needs some time. Yeah, these white edges, these are also excluded from this image memory. Okay, then we get this flat surface, using this command. We have several algorithms to segment the objects. I used clustering, and this gave me, for example, only one object in this point cloud, so this is fits for my needs. Then sorry, let me, it gets minimum. Okay, then I trimmed 5% of the lowest points and 5% of the highest points to get rid of noise. 5% percentile trimming. Then I calculated eben height, subtracting remaining maximum and minimum points. So after those trimming operations, what I obtained is this point cloud, and in this point cloud, this is in this point cloud, I find the highest point and the lowest point, then I just subtracted those. This is eben height check evaluation function. As it is given, our tolerance level is 30 microns, so I set this to 30 microns. And also one CSV file is asked, so I also prepared a CSV file. First I reset the previous global string, then I get the date, then I append the measurements in microns, then I write it to the CSV, which is located in desktop, in file, Then if my eben height is okay, if my eben height is okay, I mean less than 30 microns, then I jump to OK mark and print OK and finish this if statement. This print OK prints OK piece to this result display. If it's not OK, then it prints not OK, which is this, and this is in red. After we finish our operations, we may need to save this or this point cloud, because the background surface has more points than this object, so we don't need to have those points. They are unnecessary. So if you want to save this processed point cloud, we just need to drag and drop this methods to here, capture image. We want to save image, which is located in image memory 1, and so from now on we will also save this processed point cloud to our computer. So any problems that may occur is let me mention about those. This getting single object in this point cloud is necessary. So if your algorithm does not get single surface like this, then the following operations may give error. So then what you need to set is, no, not this one, this operation, 3D blob. You need to set or make the parameters more flexible, maybe for 16. By making them more flexible, you have option to detect a single object not many small regions. You can also use other algorithms